This video is going to explain the work kinetic energy theorem. Let's suppose we have a rider and a board moving across with some velocity, so they're going to have some kind of kinetic energy. And they're going to move until they don't. So eventually they're going to come to a rest because friction is going to slow them down. So now when they come to a rest, their kinetic energy is going to be zero. So to change their kinetic energy had to be transferred from the rider's kinetic energy, to somewhere else. Anytime we transfer energy, we call that work. So we recall that work is equal to the force parallel to the times displacement. So the force is going to be friction, and the displacement's along the floor. So in this case, work is going to be removing kinetic energy from the rider and the board. So this is the work kinetic energy theorem. If I want to change the kinetic energy, I have to do work to transfer that energy somewhere else. But for a moment, let's focus on using the prepositions on and by and how we use them when describing work. So here's a little video example. Got the car at the bottom going across the screen. So it's applying a certain force, and then the brakes are applied as it skids to a stop. So in this case, whenever the force and the displacement, that is the green arrow and the black arrow, point in the same direction, we say that that's work done by the source of the force. So in this case, the source of the force would be the car, or you might say the engine. I mean, a couple ways to place it, but let's just call it the car, not look too close at it. So the source of the force is the car. So it means work is being done by the car. Now to figure this out, it's really easy. You take one finger in the direction of the force, one finger in the direction of displacement, and when they go in the same direction, that's the by preposition. Now when it stops, it's still going to move at distance, but the force is going to oppose the motion. So in this case, the force, one finger goes one direction, and the other finger goes the opposite direction. Since your fingers go in the opposite direction, we're going to use the word on. So the force of the brakes is being done on the car. So by the car, force and displacement go the same direction, and on the car, the force that's being applied to it is going in the opposite direction. So when you're saying on the car, it's removing energy from the car. When you say by the car, it's adding kinetic energy to the car. So let's have a little bit of practice with our on and by. This little example, let's calculate the work's magnitude, so that's been done before, and we're going to describe the work as being done on or by super dude. So super dude applies a force in the direction he's flying, and the car is coasting. So the car is not adding any energy to this problem itself with the engine or anything. Okay, pause and see if you can come up with how much work is done and using the phrase on or by super dude. Okay, hopefully you gave that a little shot. Now let's see what we have. First off, super dude in the beginning is going to the left. The displacement is also going to the left. So that means the work is done by super dude. So I'm just talking about the force of super dude because super dude is the source of the force pushing the car. And on B, super dude looks like he's trying to push in the opposite direction of the car. But the car's moving left, he's moving to the right. So that's work done on super dude. So I'm removing energy from super dude. And now for C, I've got the force, and I got a component of the force parallel to the displacement. So that's work done by super dude. So he's transferring energy from him to the car. And then I have this force going in the same direction as super dude. So again, it's work done by super dude. So super dude is transferring energy from him to the car. In terms of the quantities, work is force times distance. Work is force times distance. Work is force times the component of component of force parallel to the distance times distance. So that's where the cosine comes in. And the last one, work is going to be force times distance.